In this example, we are given a rational function 3 plus x over x minus 6. And again, we are asked to find the inverse and the domain and the range of both functions. Once again, we will start by swapping x with y. When we do that, we will now have x equals 3 plus y over y minus 6. Notice that this time we have y in two positions. Algebraically, this is going to take a few more steps than our previous problems. We're going to do a move that's a little bit unconventional, though. We're going to take the y minus 6 and put it in parentheses, and since it's on the bottom on the right, we're going to move it to the top on the left. When we do that, we now have y minus 6 in parentheses times x is equal to 3 plus y. Now, our goal is still to try to get y by itself, but y is still in two positions. And notice these y's are also on opposite sides of the equation, and also one of the y's is stuck inside of this y minus 6 set of parentheses. To get it out of there, we're going to have to distribute that x. We will take x times both of the terms inside the parentheses, and when we do that, at least the y won't be in the parentheses anymore. We'll end up with x times y for xy, minus 6 times x for 6x, equals 3 plus y. However, we still have y's on the opposite side and in two different positions. We're going to have to move those y's together in order to solve this. The next best thing to do here is to at least get the y's to where they're on the same side. So we're going to take this xy and move it to the right side and subtract it. We'll end up with minus xy on the right. On the left side, the xy's will cancel out, and we will have negative 6x remaining on the left is equal to 3 plus y minus xy. Now at least we have the y's on the same side, but what we really want to do is make it to where there's only y's on that side, and so we're going to move any non-y terms to the left and let the right side be reserved for y. To that end, we will subtract 3 from both sides because that's the only term on the right that doesn't have y. If we do subtract the 3, the left will now say negative 6x minus 3, and the right will now say y minus xy. Now the y's have their own side on the right, and the left says negative 6x minus 3. Since the y's are now on the same side, we may factor y out on the right. This means we will move a y outside of a new set of parentheses, and then any terms that were on the right we will divide by y. The first term in that parentheses will be y over y, and that will give us 1. The next term is minus xy over y, and when we divide, that will cancel the y's out and give us negative x. So we can rewrite the entire right side as y times 1 minus x. The left side will not have changed. We'll have negative 6x minus 3. Now we're only one step away from finding the inverse. We've got a single y on the right side. Now we just need to get it by itself. And to get it by itself, we will divide both sides by that new 1 minus x that we just factored out. This will cancel out the 1 minus x on the right, and will give us that our new inverse is equal to negative 6x minus 3 over 1 minus x. This will be our new inverse function, and then now we can find the domain and range of our original and inverse function. Let's begin by finding the domain of our original function. Our original function has a denominator of x minus 6. Our rule for denominators is that the denominator cannot equal 0, and we'll set up the inequality x minus 6 is not equal to 0. If we add 6 to both sides, we'll end up with x is not equal to 6. Remember that x is not equal to 6 will appear as an open circle on our number line. We'll draw a number line, and then we'll put an open circle on 6 and split that domain into piece A and piece B, keeping in mind that we still need to write infinity and negative infinity on the number line. Our domain, based on this, will have a piece A that goes from negative infinity to 6, and then union a piece B that goes from 6 to infinity. Also remember that the domain of the original function becomes the range of our new function. This means since we know the domain of the original, we can get the range of our new inverse. That will also be negative infinity to 6, union 6 to infinity. Now we don't know the range of our original function, but now we can get the domain of our inverse. Getting the domain of the inverse will give us the range of the original. Since our denominator in our inverse says 1 minus x, we know 1 minus x cannot be equal to 0. So we'll say 1 minus x not equal to 0. We can add x to both sides, and we'll end up with 1 is not equal to x. Notice I've written it x is not equal to 1, but that means the same thing. So once again, we'll draw a number line, and that number line will have an open circle at 1. We'll place an open circle in that position and split the number line into piece A and piece B. This will give us a domain of the inverse for negative infinity to 1, union 1 to infinity, because we have to remember to put the infinities on the number line. This means that the range of the original function will also be negative infinity to 1, union 1 to infinity. And so now we have the domain and range of both the original function and its inverse. So by finding the domain of both a function and its inverse, you can get both ranges by using the properties of the inverse function. Thank you for watching. We'll see you again soon.